This video will help you fill out the top flap of section number 5 of your Unit 8 Trigonometry flipbook. Top flap of section number 5. Class, in a previous video, we found out how to use trigonometry to find a missing side of a right triangle when all you know is one other side and a reference angle. In this video, we're going to show you that you can actually use trig for the opposite way. You can not only find a missing side, but you can also find a missing angle. First thing I want you to write in your flip book so you grasp this is, on the top of this section, class, I want you to write this. Okay, trig. How do we use, or why do we use trig? We use trig in this way. If you know an angle, you find the side ratios, or side ratio. So in trig, you noticed when you, let me move this over. In trig, you noticed when you knew an angle or reference angle of a right triangle, you could use trigonometry to find a missing side, or the ratio of two sides. There's another thing you can do with trigonometry, and it's called inverse trig. So you're going to write inverse. It's basically trig in reverse. Inverse trig tells us if we know the sides, find angle. So trig takes a known reference angle and spits out the values of the sides, or the side ratios. Inverse trig takes the known side values and finds a missing angle. So in this section, we're going to actually use trig in reverse, or use inverse trigonometry. Let's take a look at how to do this. Here's your essential question. How can I use inverse trigonometry to find the missing angles of a right triangle? So let's go ahead and scroll up, and we'll go do this. Here is a sample triangle, right triangle, ABC. We know the lengths of the two legs of this triangle. And the question is, what is the measure of angle A? What's the measure of angle A? Now, class, I'm going to solve this pretty much the same way that we solved missing sides. The first thing you should know is write SOHCAHTOA, because we have to figure out what trig ratio we're going to use. All right, let's figure out what our reference angle is. Our reference angle is, it's going to be A, because we want to find A. So the reference angle is A. All right, let's take a look at the two sides we know. If our reference angle is A, then the two sides we know are BC and AC. BC and AC. So we can pick either one of these. Let's go ahead and pick the opposite side. Okay, so CB, one of our known sides. Actually, you know what? I've got this written down wrong in my notes. Just hold on a second, class, as I figure this out. We're going to write down that we know that AB, oops, we don't know AB. We know that AC is adjacent to reference angle A, and we know that CB is opposite of reference angle A. So we know the adjacent and the opposite. Let's figure out what our trig ratio is going to be. Well, we know adjacent, so I'm going to underline A. We know opposite, so I'm going to underline O. Looks like we have to use tangent to figure out this angle measure. Alright, so let's use tangent, but we're not going to just write TAN, because we're not using regular trig, we are using inverse trig. If you look at your calculator, you'll see a button that says tan of -1. That's the inverse function of tangent. So tan of -1, or inverse tangent, and think of what tangent is. Tangent is opposite over adjacent is equal to the measure of angle A. So now you see what inverse trig does, class. In regular trig, we plugged in the measure of our reference angle, and out came the ratio of the two sides. In inverse trig, we plug in the ratio of the two sides, and out comes the measure of the missing angle. So let's rewrite this and plug in what we know. Tangent, or inverse tangent. Opposite is CB, that's 15. Adjacent to angle A is AC, which is 8. So tangent of 15 over 8 is going to equal the measure of angle A. All right, let's go ahead and plug that into our calculator. So I'll bring up the calculator. Let's move it over to here so we can see. All right, so we're going to use the inverse tangent button, inverse tangent, and now class, you can just put this fraction into the inverse tangent function. So 15 divided by 8, close your parentheses, press enter, and you just found that that angle, measure of angle A, is approximately 61.9. So that means, I'm going to rewrite this, the measure of angle A is approximately 61.9 degrees. Let's go ahead and label that. 61.9 degrees. Okay, now, there's another way to do this quickly. I'm going to run out of time, so I want to hurry on this. There's another way to do this. I've covered this in class probably by now, maybe not. But you can actually use your trig tables to do the same thing. So, in the back of your flip book, there is a trig table. So let's try to find the measure of angle A using your trig table. So using the trig table, we have to figure out what 15 over 8 is approximately. If you put that in your calculator, you're going to get approximately 1.875. So in our trig table, let's pull that trig table up. 1.875. Look under the, let's take a look here again. Hang on a second. We're using tangent of 1.875. So tangent, find tangent of 1.875. Okay, here's a tangent column, 1.804. This is the closest we get, 1.875. The closest degrees in our table is 62 degrees. So using our trig table, we're going to get the value of the measure of angle A is approximately 62 degrees. You can see how close it is. Notice your trig table is not going to be as accurate as your calculator. All right, I've got to blow through these real quick because we are going to run out of time. Take a look at what's the measure of angle B. You write so, ka, and toa. SOHCAHTOA. Okay, let's figure out our reference angle. Our reference angle is going to be B now because we want to find angle B. All right, what do we know based on angle B? We know that AC is opposite. And we know that CB is adjacent. We don't know the hypotenuse. We have opposite is AC, adjacent to angle B is CB. Let's write our trig ratio. We know opposite and adjacent. You see it works out pretty much the same. We got opposite, opposite, adjacent, adjacent. Looks like we have to use tangent for this one as well. So tangent, or inverse tangent of, remember tangent is opposite over adjacent, is equal to the measure of angle B. All right, let's rewrite this and plug in what we know. Inverse tangent. Our opposite value is AC, which is 8. Our adjacent side, which is CB, is 15. So now look, now we're doing tangent of 8 over 15 to find the measure of angle B. To find the measure of angle A, we did tangent of 15 over 8. All right, let's plug this into our calculator, and the measure of angle B is going to be approximately, let's slide this over a little bit. We've got inverse tangent, whoops, it's clear, inverse tangent of 8 divided by 15, close our parentheses, and we have 28.07. Let's round that to 28.1. It's approximately 28.1 degrees. If you looked in your trig table, you'd find close to that answer, 28.1. You'd actually get 28. Now, last thing you should do, class, is make sure always you label your diagram as you go. This is 28.1 degrees. Let's check and see if our work is accurate. We know these angles have to add up to 180. So let's go ahead and do a check of our work. 90, there's our 90-degree angle at C. 90 plus 61.9 plus 28.1. Put that in your calculator, you will get exactly 180 degrees. Everything looks good. Alright, let's do one more example. Triangle GHF. What is the measure of angle H? Alright, first thing, class, you write SOHCAHTOA. I'm going to go quick on this now. Again, I want to save a little bit of time. SOHCAHTOA. What is our reference angle? You should be doing this on your own, by the way, and then just checking the video. Reference angle is H because we want to find H. We know that GF is, compared to angle H, it is opposite. The other side we know is HF. That is our hypotenuse. So we know opposite and hypotenuse. I will underline opposite and opposite. Hypotenuse, hypotenuse, we're going to use sine. So here's our equation. Inverse sine of opposite over hypotenuse is equal to the measure of angle H. Let's plug in the values. Inverse sine of opposite is GF, that's 22. Hypotenuse is HF, that's 29. Is equal to the measure of angle H. And that means the measure of angle H is going to be approximately, let's plug this into our calculator. I'll slide this over. We're going to type in inverse sine. There's our, oops, let me clear that. Inverse sine, 22 divided by 29, close parentheses, press equal. Our angle measure is approximately 49.3. 49.3 degrees. I'm going to label that angle H. 49.3 degrees. Let's find the measure of angle F. SOHCAHTOA. Our reference angle is of course going to be F now because that's the one we're looking to solve. We know that GF compared to angle F, GF is now adjacent to our reference angle. HF is still our hypotenuse. Our equation is going to look like this. Oh, let's find out what we need to know. We've got adjacent known and hypotenuse known. That means we're going to use cosine. So this time cosine of -1. We know cosine is adjacent over hypotenuse, and that's going to be the measure of angle F. Let's plug in what we know. Inverse cosine. Adjacent is GF, that's 22. Hypotenuse is 29. That's going to be the measure of angle F. And that means the measure of angle F is approximately, let's plug that into our calculator. Inverse cosine of 22 divided by 29 equals 40.65. We're going to round it up to 40.7. So this is 40.7 degrees. Let's label that. 40.7 degrees. And let's check our work. We got 90 plus 49.3 plus 40.7. Add those up, class. You will get 180 degrees. We know that our angles are correct. Here's how to find missing angles by using inverse trig.